logics. The topic is tri-state inverter. In the tri-state inverter, up to now we have seen that inverter has an only two state where it will be having one input and one output. It means it will be having only two terminals, one input and one output. But when we come to the tri-state inverter, you'll be having the three different kinds of terminals have been used. One is input, second one is output, and the third one is called as a control signal, which is also called as an enable signal. You will be using enable or a control over here in the tri-state inverter. So this is the tri-state inverter diagram where you, depending upon the enable, depending upon this control signal, the switch will be open, or and again in this case, whenever enable equal to 1, the switch will be closed. So let us see now this operation of tri-state inverter, and there are like 3-4 slides which tells about tri-state inverter operation. In the next coming slides, you can see that one. Here in this one, this it is also called as a buffer circuit also. Digital buffer circuit whose output can be electronically disconnected from the output of the circuitry whenever is required. If you don't, if you want to disconnect the input from output in the inverter, you can use this enable one. Whenever this enable is open, whenever the enable equal to 0, the switch will be open. So it means a transistor will be open. Because of that one, a input cannot be passed from input to the output. So at that time, what happens if input is not passed from input to the output, or else whenever enable is equal to 0, your output will be high impedance. High impedance means totally it will be in the high resistive state. So even if you put it in software also, it will show like Z as an output. Z means it is in high impedance state. So that's why Q is equal to output equal to Z. But whenever the switch is equal to closed, it means whenever enable equal to 1, the input will be passed to the output. This type of inverter is known as a three-state inverter, or more commonly it is called as a tri-state inverter. So now let us see the operation of this one. A tri-state inverter can be thought of as an input controlled switch or input controlled device with an output that can be electronically turned or turned off depending upon a control signal or enable signal, which is denoted by EN over here in this diagram. This control signal can be either logic 0 or logic 1 type, and because of this logic 0 and logic 1, which also results in tri-state inverter being in one state of operation, it means that it will be allowing its output to operate normally by producing whatever is being supplied at the input, by producing only the required output, and in another state your output will be totally blocked. Because of that one, that disconnection takes place between the output and input, and the output will be obtained as an high impedance that is equal to Z. Then the tri-state inverter requires two inputs over here. That is input A and enable. These are the two inputs. One being the data input. This will be the information which has to be passed, and the other will be the control input. Now here, when activated in its third state, it disables or turns off. It means that its output producing an open circuit. Open circuit means what? Whenever this enable equal to 0, if enable equal to 0, what happens? It will be completely turned off. Because of that turned off, your output will be see now, it will be an open circuit condition. That is neither logic 0 or logic 1 will be obtained at the output. But in fact, instead of this obtaining logic 0 or logic 1, your tri-state inverter will be producing an output of high impedance, which has been denoted as Z. Then this type of device has two logic state inputs, 0 or 1, but can produce the three different outputs. That's what are the three different outputs? It can be 0, 1, or the third kind of output is called as a high impedance, which is Z. Which is why this is also called as three-state device or tri-state device. The main reason why it is called as three-state device is that it will be producing three different types of outputs: 0, 1, and high impedance state. Here, not equal is a logic 0 or logic 1, but here in this what happens? See, logic 0 and logic 1, it's nothing else but it's a NOT gate operation, which is nothing else but your CMOS inverter. But apart from that one, here you'll be also getting a high impedance state in which a buffer or inverter is totally electrically disconnected. Disconnection takes place. And this is regarding what happens in your tri-state inverter. Now let us see the four different types of operations of the tri-state inverter. That is active high, high, active low, are the two different phases where you will see how this circuit will be operated, producing an inverted output and also non-inverted output. So let us see that one now in the next slide. See, the first case is active high state, high tri-state buffer. So this is the condition. This is a truth table for the active high state buffer. If a data in is been supplied, depending upon this enable, whenever the enable equal to 0, if enable equal to 0, what happens? The disconnection takes place. And here, since there is disconnection, even if you supply input as equal to 0, the disconnection will be between the input and output state. Your output will be completely high. High impedance. Even again in the same enable state, even if you supply input equal to 1 also, because there is a disconnection, the circuit is open between input and output, your output will be always high impedance. Now, whenever enable equal to 1, if enable equal to 1, then whatever the input you supply over here, that will be passed through the output. It means that since it is an inverter, if you supply here input equal to 0, say, and depending upon the enable, the circuit is closed now, closed, the same input will be passed to the output, that is data in 0 will be equal to 0. And data in, if it is equal to 1, it will be 1. Don't think that since it has been named as an inverter, it will not be inverting the circuit. It will be acting as a buffer. So that's why I have written here tri-state buffer. Buffer means it will not be the input you supply at the input level, it will be same passing the same output. That is called as a tri-state buffer, or you can name it as even tri-state inverter. This is regarding what is the operation of active high state tri-state buffer or inverter. This is one of the example of active high state buffer. That is this one of the chip which is used in order to have this kind of operations. Now, active low state buffer. In the active low state buffer, what happens? In the active low state, you are trying to put this enable bar. Enable bar means you can see now the inversion takes place over here. In the active low state, the control signal will be a complement, and that will be again inverted over here. So now an active low state tri-state buffer is an opposite to the above active high state buffer. Above means active high state buffer, which is activated whenever logic level is equal to 0. Means whenever you supply this, here it is 0, then because of this one, what happens? The inversion takes place here. Inversion takes place because of that one. The chip, so buffer will come into closed state. Will be in closed state. So whenever the buffer is closed state, you can see the operation. Whenever the enable equal to 0, since it's an enable bar, 0 means what? Here if it is 0, now because of the inversion it becomes 1. Here the input which is given to that control signal, male control signal will be 1. Because of that one, the switch will be closed, and whenever the switch is closed, the same input which you supply over here will be outputted to the output. The similar way, since switch is closed in the same state of operation, that's enable equal to 0, the input 1 will be same outputted at the output. But whenever it comes to the enable equal to 1, whenever enable equal to 1, the inversion takes place. Because of this inversion, the switch is closed now. Here the switch which is closed will become now open, and the disconnection takes place between the input and output. Whenever a disconnection takes place, whatever the input you supply as an information at the input level, it will not be passed to the output level, because there is no path to pass that information right from input to output. Because of that one, the output will be always resulting a high impedance, that is called as an high Z, will be given as an output for both this operation, both the logics of the inputs, whenever the enable equal to 1. This is regarding active low tri-state inverter or tri-state buffer operation.
Sir, enabled at low level and sir.
Where show me?
Enable 0 low logic level 0 ఇచ్చినప్పుడు enable అవుతుంది కదా sir.
Yes, see now. Logic level 0, see here, whenever it is logic level 0, what is happening here? Inversion is taking place. One inverter is connected. One bubble, you can see this bubble or not? See, whenever it is 0, the input which is connected to the switch will be 1 because of this inverter. See here, what I told, whenever it is 0, if I go back to my slides, you can see now, whenever it is enable is 0, what happens? The switch will be open. Because of that one, the disconnection takes place. But when you come to this active low state, In the active low state, what is happening here? Because a bubble is connected at the switch, that switch will become, if I supply 0 over here, because of this bubble, that here the output of this one will be 1, and that one of the enable will make your switch to close. So that's why whenever enable equal to 0, whatever you read is correct only. As per the truth table, whenever enable equal to 0, the output will be resulting. You'll be getting some output over here. But whenever it is a 1, you'll not get any kind of output. It will be high impedance. Is it okay? So this is regarding tri-state inverter or tri-state buffer. You can see now this is acting as an inverter. This acting as an inverter whenever it is active low inverting tri-state phase. In this one, it's a non-inverting tri-state phase. Here the truth table is regarding a non-inverting tri-state phase. Means what? Here it is acting as a buffer. When it comes to this phase, it's an inverting tri-state buffer. Means it will be producing an inverting out. If you supply 0 as an input, your output will be 1. If you supply input as an 1, your output will be 0. So there are 4 different levels. Active low state and active high state will be having 2 different levels in itself. First one will be active high state inverting state, active high state non-inverting state, again active low state inverting state, and active low state non-inverting state. If you see the two tables, you can understand that one. In this case, you can see here now, in this case, it's a non-inverting state. It is acting as a buffer. If you supply input 0, the same output is obtained here. If you supply 1, the same output is obtained. But when it comes to the next level of this active high state, it will be non-inverting state. So, sorry, it will be an inverting state. If you supply input 0, output will be 1. If you supply 1, the output will be 0. So these are the conditions for the tri-state inverter and tri-state buffer.